Okay, hello, welcome to this walkthrough. I'm going to be covering the Enter the Matrix case by João Bosa. This was the community case this week. I'm being maybe a little bit premature in that I'm recording this before the case has actually ended, although I obviously won't post it until afterwards, partly because I find with this process, like once I've done a case, if I don't get it all right, I kind of have to work out how it's done, and my brain can't leave it alone until it's done. So the sooner I get it done, the better. So I have managed to get the answers through the Master Excel or Excel Master add-in. So as we go through this, we'll be able to know that these are the correct answers. So I'm not going to waste any time there. Also, to make this quicker and more efficient, because it was a 40-minute case, and I don't want this walkthrough to take 40 minutes because it shouldn't take longer than the case itself to explain it. I've done some work to kind of set my spreadsheet up so we don't have any time wasted as we go along. However, there are a couple of bits that are quite complex, and so I might potentially just pause and check my previous version to make sure I know what I'm doing, so you're not stuck listening to me umming and ahhing about my way through it. So and I will save my kind of comments on the case and how I did mainly till the end, although I might say a little bit as I go along as it seems appropriate. So yeah, with that being said, we're already a minute and 20 seconds into this video, so let's get going. So Enter the Matrix, we're going to do each level as a data table just so it's nice and easy to work. So this level we get given the pulses, or we need to do our data setup, tiny bit of work, so let's just grab these and define the names from the range, and we'll do the same for the lifts as well. And then we'll also do the same with the matrix array, and we'll just select that and call that MP for map, which seems to be the general convention. Okay, so we are going to level 1. So we're given pulses separated by pipes, and we have to work out what letters and what word they spell out. So we're going to text split B1 based on the pipe separator. We will then X look up each of the pulses in the letters, and then we will concatenate that array there, which gives us Neo. And when we point to that, we should get all the correct answers, and it's nice because we can see they're all recognizable words, which means you kind of don't even need to really know if you're correct or not, you can kind of tell. Okay, on this one we are given some numbers referring to the different pulses, and we have to basically work out which letters could we in theory make up based on those. So we need to grab the pulse, if I type the full name. And then what I want to do is I'm going to use the count occurrences lambda, where I'm going to count the occurrences of each of the pulses in each of the pulses, which is a bit of a mouthful. For some reason I've put a minus in front of there. And then what do we need to do? We need to check that these numbers here are, let's think about this, that's how many we've got. So we need to say that they are less than or equal to the numbers in what we've been given our resources. So we get trues and falses, and then if we wrap this in a by row and say and, so we want the rows where they're all true, so that all the letters are there, and then it asks us to return the letters themselves. So let's filter the letter based on where that is true, and then let's just concatenate that, and in the example we get AIO, which is correct, and so we can just point to that for our data table. And again, not possible to check these intuitively because they don't spell out words, so unlike the previous level. So level 3, this time we're given again some pulses but also the splits between them, and that will help us to work out the letters. So what we can do is we need to grab what the splits are. So they're in cell C1. We're going to split them by a space and multiply by 1 to return them as numbers. And then what we're going to do is build this one step at a time. So we're going to scan starting on 1 because we'll always start at the first level, and then we're going to go through this array and we're going to sum that array, but that actually misses off the first starting point. So actually what we're going to do is we're going to v stack a 1, and then we're going to drop from that final array the last level, and it gives us 146. And then we can use mid, where we say we want to take the text in B1, these are our starts, these are our splits, and now we're back to the same as level 1. So we'll concatenate the X lookup of the pulse returning the letter, and we get Neo again, who's our example on most of the layers. And again, this time we can see the words, so we would have known when we were doing this whether we were on the right track or not. Then level 4, so this time we've got two letters stuck together, but we don't know where the boundary is. So this time I'm going to take the length of the terms. So if there are 5 letters, then there's 4 possible splitting points. So what we're going to do is create a sequence of the length minus 1, and then we're going to try each of the splitting points. We're going to take the left of B1 for each of these, and then we're going to take the right for B1 of each of those, but taken away from the length, so kind of going in reverse order, and that gives us the rights. And then we will check each one to see if it appears in our list. So we'll X look up these in our pulse and return our letter, and we'll just fill that to the right, and we see we've got some letters appearing. The only row where there's both letters will be this one. So the quick way to kind of filter those out is to say, well, let's take all of these, join them with the numbers, and join them with the right letters, and where we don't get an error, that will be the correct answer, because it's the only one where we don't have an error on any row. And we can use 2col and the optional 3 input to get our answers. And again, now another one where technically we don't know whether we're right or not, but those should all be correct, which they are. Let's go on to level 5. So this time we're given no markers, no hints, just the pure stream. So what we're going to do is we're going to start by just pointing to this, and then we need to work out what the next letter is. So I'm going to build this one step at a time. So we're going to firstly work out the length of that. So there's 7 characters. So then let's wrap that in a sequence of those 7 characters or 7 numbers. Then we're going to wrap that in a left function to get each of the possible, something's gone wrong there. So we're going to go left of the E3 on each of those possibles, so we get all the possible lefts. And then if we let X look up those in our pulse and return a letter, only one of them is going to return a letter, in this case N, which we know is probably going to be for Neo. And then if we use our 2col and our 3, we then get that the next letter is N. So we know that first bit of that will be the N. So what we can then say is, right, let's look up our N in our letter and return our pulse. And that's the bit we need to remove from the front of this, or rather we want to take the text after the cell above, which is D3, sorry, E3, and then, can't type, and then close that off. And so, oops, something's gone wrong because I put DE3. And it's not D3, it's E3. There we go. So that's what's remaining once we take off the N. So if we then fill that down, and then let's fill this down for lots of rows, and we can see our letters appearing. So the simple way here, this isn't very dynamic, and I might say something about that at the end, but for now, to save time, I'm just going to call that, not concat, I'm going to call it, and then I will wrap it in a concat. And it's not a dynamic range, so I can't use a dynamic formula. And then I will wrap that in concat, and that gives us Neo, which again is our answer. And again, we get words that help us realize, yep, we're on the right track. And I will come back to this level later, explaining how I got messed up on this in the real case. But let's move on to level 6. So level 6, we're now looking at the matrix code. We're going to be given a cell and told to start at that cell, go down to some number of cells, and grab the glyphs, and then return the word. So let's grab firstly the row number of that B1 and the column number also B1, and what we want to do is we want to see the positions of the original kind of column. So we're going to just grab a sequence of 67 because there's 67 in the rows, and what I'm going to do is I'm going to index into the map, and I'm going to grab the column number that we had. So those are our 67 possible values, and then what we want to do is we actually want to grab everything. In fact, I've done this slightly differently to how I did it before, but it's fine. So what I'm wanting to grab is everything from row 51 plus 8. So let's create a sequence, and it's going to be the value in C1 plus 1 long, and it's going to start at row 51. And those are, so we want the things in positions 51 to 59. And so what I'm going to do is I'm then going to index into the values column into those positions. and it doesn't like that because I accidentally created a multiplication. And those are the glyphs that we start off with. We now need to know which of them actually are proper glyphs and not just noise. So I'm going to filter that list based on those that exist from that list within our glyphs list. So we actually have only 7 characters. I'm then going to concatenate them to get a text string, and this is where I'm going to grab my workings from the previous level. I'm going to put that in here. I'm going to point that to here because that's what it's next to. And again, we get Neo. And so what we need to work out is how many did we not use? So we had this many before, this many now. So I'm going to say count the rows in here minus the rows in our filtered list, gives us 2. So our final answer is going to be that and a / and that, which gives us Neo 2, which if we point to that, gives us all the correct answers. Okay, moving on to level 7 begins to get really complicated. So again, this time we're given a cell, a number of kind of rotations or drops. I'm using the word rotation because they can go back to the top, and then the number of kind of the size of the string to look at. So I'm going to start by grabbing the row number of the cell we're starting in and the column number as well of cell B1. And so we want to grab the column value. So let's index into map and grab the column. So that's all the values, and then the original positions is just a sequence of 67. So this is their original positions. I'm going to move this over, and we want to know their new position. So the new position is we take this and we're going to add 3 times the value in C1. Okay, so cell 1 originally is dropped 60 places, 20 times 3, so it's now 61, but we need to sort out the looping. So we're going to put this inside a mod, and we -1, we mod through 67, and then we +1, so we're not dealing with the zeros. Okay, and what we're looking for our start position, and it took me a while to get this, and I kind of solved it before I really understood it, saying we want to know what will be in cells A528 after all the movements have happened. So basically what we want to do is we want to X match the row number in the new positions. So it's in 35. So in position 35 now is the thing that was originally in, or the thing that's going to be in 28, it was in 35. I still think I'm not explaining that very well, but so let's keep moving on so we're not wasting time. So we now need to know a sequence from the 35th position up to of 22 places. So we're going to do a sequence of the value in D1 starting at the value in J1, and then we're going to index those into the column values in those positions. So we get the kind of, in this case, 22 values we want to look at. And now again, we're going to filter that list based on where that list exists, that list within the glyphs list. And then we're going to concatenate that, and we get our string. And I'm going to grab the workings this time from level 6 because we've already kind of updated the lookup location. And so this time we get Trinity, and also our final answer is going to be that and a / and the start position. So we get Trinity 35, which was the answer in the original, and we see that we're all correct. Okay, how are we doing on time? So we've done 13 minutes for the whole video for the level. So let's go on to the bonuses, which were very challenging, or the last one was very, very challenging. So adding up all the 26 pulse codes, how many times does this particular glyph appear? So if we go to our glyphs, if we concatenate the the pulse, and then we can say count the occurrences of, it's this top glyph in that, and we get 21, which we will put in here. And then that's correct. How many of the 26 postcodes contain all 3 glyphs? So we're going to do something similar to, I think it was level 2. So let's 2 row the glyphs, and then let's just put the pulses here. And we want to know how many of them they have and how many have all of them. So let's do this. We want to, let's use count occurrences again. So we've got occurrences of the glyphs within the pulses, and we get those, and we want to what do we want to do? We want to know those where they have one of each. So let's go to by row this and we get those where it's got a number for all of them, and then it actually wants the letters, I think. So oh no, just wants to know how many of them contain all three. So we just want to wrap that in a sum minus minus, and we get 10. So 10 is our answer there. Yep. Which of the 26 letters have palindrome pulse codes? So we've got our pulse over here. So let's take our pulse, and then let's take, I've got a reverse lambda. Does it take a dynamic array? Yes, it does. Let's go if that equals that. No, that doesn't like that. I think it's reversed the whole array, hasn't it? So let's do it one by one. So let's take the reverse of that, and then we'll say that equals that, and let's fill that down, and then we want to filter the letter where that is true. Oh. I thought it was a dynamic array, but it's not. So it's this array here, and we get those, and we'll concatenate those, and let's copy that over here, and we'll paste it. Okay, I'm going to go to bonus 4, which I did not understand during the real thing, and I've now done a bit better and now understand it. So in the matrix range tab, in which columns is the glyph, whatever that's called, the most frequent pulsed glyph? And it means within that column compared to the others. Whereas I was thinking, I counted how many times that appeared. So I'll explain, we'll show you what I did. So here are the glyphs, if I can type properly. And what I'm going to do is I'm going to say the sum of this range, because there's gaps here, it takes a little bit longer, equaling, let's point to this value here. And we get 8. And if I I'm going to lock the rows on that range and the column on that range, so I can then drag this across, and then I'll drag it down and then drag it across. And now what I did was I only did this first row, and I was looking, right, well, column H has 11, and that's the most, so I assumed H was the answer. But what it's actually looking for us to do is say, right, if we say we want to know where the ones where the kind of N-shaped one is the max, and we ignore it where it is a tie. So we say where, and this is greater than that, and that is greater than that. In other words, we want the cases where the top number is bigger than both the others, and we will go along and fill that to the right. We can see the columns with the ones are the ones where that is true. I'm going to just zoom out a bit. So now we need to get the column letters for those ones. So the way I'm going to do that, I'm sure there's a quicker way, but never mind. So I'm going to take the address of row 1 of the current column number version 4. I'm going to fill that to the right, and then what I'm going to do is I'm going to extract the text from that and do the same thing, fill it right. I get all the column names, and because there's more than 26, we can't just use an alphabet, and then I'm going to filter those columns where that row equals 1, and then I'm going to concatenate that result to get my letters, and I go back to the home page and we get that correct. So now we're going on to level bonus 5. So we've done just coming up to 19 minutes. So let's get on to bonus 5. So how many times do the words white and rabbit appear? When you see the preparation work I've done, you're going to go, okay, this is why this was a particularly difficult case or bonus. I mean, you could have given me 40 minutes on this bonus and I probably wouldn't have done it in time. But anyway, I'll give it my best shot now. So I've set up, we're going to go through every column and try and find whether the word appears. So we're going to start by indexing into the map for this column. So that's what we've got. We then want to know which of those are text. So we're going to filter this where is text, that, because we want to filter out those which are empty. Then we need to know those that are glyphs, so we're going to filter this where exists on that is in our glyphs list. So we've now got, in this case we've only got 7, so let's concatenate them. And we don't actually need our kind of conversion to word thing from level 5, 6 and 7. We can actually do this another way, because we can actually just we can work out what the string would be for these words. So for white, if we use text characters of white, we get obviously the letters for white. If we then look up those in the letter and return the pulse, we actually get the pulses, and then if I wrap that in a concat, we get the actual text, and we can use this information. So this is the strings we're looking for within here. Now this one it's clearly not going to be because that's longer, so it can't possibly be contained. But what we're going to do is we're going to say, is it a number if we search for actually it's probably just quicker at this point to point to it, search for that within that, and we want to return that as a 1 or 0. And I'm going to copy that over and just point this to the correct cells. So we haven't got either, so we're going to just say whether we found is the sum of these, because if it can only be one or the other, so we don't end up with one. And what I'm going to do, I'm going to be a bit cheeky here for the explanation. I'm going to go to column 6 because I know actually column 6 is one where we do find it, so the rest of this makes sense. So the next thing we need to do is work out the position of all of the characters, these glyphs within this list. So I'm going to firstly take a sequence which is the number of rows that were actual text, because we ignored numbers. So in this case there are 67 max, but we only have 58. And then what I'm going to do is I'm actually going to join that using a pipe and the actual symbol itself. So we've got the symbol and its position. And then what I want to know is I want to then basically get the ones that are actually real glyphs. So I have to kind of think about this quite carefully. So I'm going to filter this list where, and then use the same filter we use to get our is glyph list. So filter that list where exists this list within glyphs. Okay, so we've now got just the positions of the glyph. So this went from 29 to 55. Okay, so now we need to know what word we're dealing with. So what we're going to do is lookup 1 in this range and return that range. So in this case we know the word white appears, and so we want to know what are the characters we're dealing with. So we lookup white in this range and return this range, because what we can then do is say, right, search that within the original string, and it tells us the white can be found at the second position. So the second position in this list is where we're going to be starting. Then we've got to work out where this ends. So this gets a little bit complicated. So we need to know the length of this, which is 12, and we're going to add that. We're going to say that starts there, but I have to be careful because sometimes we have to add a 1 or take a 1 away when we're kind of dealing with ranges, and this will become more obvious in a moment. So in this case we are going to create a sequence that is this many characters long starting at this character, and that saves us 2, 3 to 15. And I'm just going to pause and just double check my work so we don't waste any time while I think this through. Okay, so what we're saying here is because we know this the word white starts at the second character, we want to get the second character through to what we think might be the 14th, but actually we need to -1 here because otherwise we go over by 1. So then what I'm going to do is index into the list of glyphs and their positions using this sequence. So we know that this list here is 13 long, which is the kind of length we're looking for, and it gives us all the characters that actually return part of the white string. I then want to get the numbers from this, because that gives me my permissions, because we have to know the total length of the string including the noise. So in this case we want to grab the maximum of that and the minimum of this as well, and that tells us that it goes from 51 to 31. And so we're going to take the difference, which is that minus that, and we can see that actually there's a difference of 20. But again, this is where we might have to be a little bit careful with the +1 and -1. So yeah, already I can see that's not right, because what we should have done is we should have taken -1 off the length of this sequence as well. So the maximum one is 43 and 31, which is a difference of 12, but then we have to add that one back on. And again, I don't want to spend too much time worrying about this here, but the issue is because we actually missed one out here. So although there are 12 numbers here, there's missed one out, and that kind of explains the difference. I'm doing a terrible job explaining this, but I don't want to waste anyone's time. Maybe we'll do it afterwards. So what are we actually looking for? So we're then looking to so we're going to set up our data table. So the word count is whether we found something, and the number of lifts is this total here. And so when we set up our table, Alt-DT, based on what's in A1, we get all of our values. And then what I'm going to do is I'm going to sum these two columns, fill that to the right, and something has gone wrong here. Oh yes, because I'm counting one even when there's nothing here. So what we need to do is, because we're adding one here always, what we should do is change this to, instead of adding one, we add whether we found one or not, and then that way we'll get rid of the zeros. And I've realized I got myself in a slight pickle, and I've realized the mistake. I shouldn't be using that difference there. I need to be using the length of the characters as my point there, and then we end up with 5 and 88. And if I combine that into a single string joined by an underscore, we get 5 underscore 88. And there we go, we've got all of our answers. How are we doing on time? 26 minutes 40 for the whole video. There was about a minute and a half of introduction, so 25 minutes or so just to explain that, working at what feels to me like a very fast speed. So obviously definitely doable within the time. I know a couple of players did do it within the time, although it was a 40-minute case rather than a 30-minute case, so I don't know how that would have changed. But yeah, I've found this really challenging, and as I said at the beginning, when I do these cases under time conditions, I feel I almost have to do this process afterwards to kind of purge myself of all the thoughts and ideas and queries and questions. So, and you can tell just by my kind of explanation there on bonus 5, I'm still struggling a little bit with these bits to do with the range and the sequence and getting everything together. But yes, very, very enjoyable, very, very difficult, definitely a hard case, but useful. And just to explain how, I mean, I did poorly in the live version. I basically did levels 1 to 4, level 5. I think level 5 I managed, but then level 6 I got stuck, because what I did, this bit of working here looks a bit more compact than it did, because there's about, if you think I've got 1, 2, 3, 4, 5 different functions being used here, and I did those one per column. So my first kind of iteration was already 6 columns wide, and stupidly, because I had some of them were spilled arrays, I didn't put the next row one underneath. I built it out to the right, and as you know, some of these are 9, 10 letters long, so I had to do 10 times 60 columns. So my thing just became stupidly wide, and I then tried to convert it into a lambda, and there were too many steps, and it crashed my Excel. And I didn't even think to try and kind of just copy it over, because actually, if it was working, I could have just copied it over here and kind of made it work, but I didn't. So that's a valuable lesson. I did spend some time while I was going through this, seeing if you could turn this into a single cell lambda. It is definitely possible, because you basically would iterate through and keep going until you've done all the letters, and then that would be it. But that's, by the time it would take me to explain that, I think it's just not worth it, because actually this is a relatively workable method ultimately. But yeah, there we go. Hope you found that helpful. Even if you didn't, I find this really helpful to go through this process to force myself to learn the case and understand it, although in this case, in this instance, not particularly great understanding of some of those more difficult parts towards the end. But there you go. Thanks for watching.